How do we know the equation of a parabola? What distinguishes the equation of a parabola from the equation of other things? It's got a squared term, just one. It's got an x and a y, but only one of them is squared. So, let's talk about that for a second. Let me get you used to kind of a new way of writing the equation of a parabola. First of all, would you agree that's a parabola? Yeah, you got x's and y's, but only one of them squared. Okay. If you wanted to, you could solve this for y. So if you wanted to, you could rewrite this equation like this. And that form is more familiar to you because that's what we looked at when we looked at quadratic functions earlier in the year. Would you agree with me? However, for purposes of what we're getting ready to do now, we're going to write our equations, well, actually, I am. You can write them any way you want. I mean, certainly it's your personal choice. But I'm going to be using this form. What I need you to understand is these are the same equation, right? Same equation, just written differently. Either way you write it, you can see that the vertex of this parabola is where? Either way you write it, where's the vertex? 3, 2, 3, 2. Write 3 up 2, or write 3 up 2. Notice if I have it in this form, it's whatever's in the parentheses, it's the opposite of that. We're kind of used to that. In your homework last night with the circles, if your circle was x plus 1 squared plus y minus 2 squared equals 4, where was the center of that circle? At -1, 2, right? Opposite, opposite, and that's the form I'm using up here. So my vertex is going to be at 3, 2. Turn this off. So it quits dinging. There we go. Okay. So my vertex is at 3, 2. Now I need you to, this sounds so obvious, but I need you to pay attention. Always x comma y. So no matter what order the equation comes in, your ordered pair is going to be x comma y. Now, this parabola opens which way? Up. If you have an x squared parabola, it's going to open either up or down. It's a quadratic function, y equals x squared, one of your basic functions, right? BFFs, it opens either up or down. What distinguishes whether it opens up or down? The sign of this coefficient, or it's here if you write it in this form. If that's a positive number, we're going to open up. If that's a negative number, we're going to open down. You already knew that, right? So we've got a parabola with this vertex, and it opens up. Now, gang, what if the y had been squared?
It would open to the side.
Then it would open to the side, left or right, and the sign of that number is going to control that. Positive will be right, and negative will be left. Now, so far so good. Now we're going to get into the new stuff. Well, it's not new, you did it last year, but it's new for us. Parabola, by definition, set of points in a plane equidistant from a point and a line. Now what that definition means is, if you have a point and a line, if you pick this point, let's say, that distance and that distance would be the same. And if we picked this point right here, that distance and that distance would be the same. If you took all these possible points and put them together, the shape you would get would be a parabola. All of the points on the parabola, like this one right here, that distance and that distance are the same. It's equidistant from a point and a line. The point has a very special name. Anybody know what we call that point? It's called the focus. Anybody know what we call the line? Directrix. Now you're sitting there with this glazed look on your face. You've seen those words before. You did this last year. You found the focus and the directrix. So that's our job now. Where is the focus and where is the directrix of this line? Or of this parabola, I mean. Where's the focus and the directrix?
The focus is the one that's not on the parabola.
The focus is going to always be on your axis of symmetry. So everybody understands what we mean by axis of symmetry, right? If we folded the parabola in half, this is the dividing line right here. Now what do you know about every point on that line?
It has a thing of 3.
Every point on that line, what do you know about it? X equals 3. So we know our focus has an x coordinate of 3 because it's on the axis of symmetry. This distance right here, which is the distance from the vertex to the focus, is traditionally called P, not sure why. That is the distance from vertex to focus. If you write your equation of your parabola in this form, this number will always be 4p. So if 4p is 4, then p is 1. And that means that the distance from the vertex to the focus is 1 unit. So if we go up 1 unit, what's our y coordinate here? 3. Now remember this word, equidistant? If we go up 1 to put our focus on there, guess what we're going to do to get our directrix? Go down 1. So your directrix is a line, and it is the line where y equals 1. My vertex was at 2, I came down 1. This segment right here goes through the focus, kind of parallel to the directrix or perpendicular to the axis of symmetry. That segment is very special. Anybody know what the name of that segment is? I think you did this last year too. Maybe not. That blue segment is called the Latus rectum. Does that sound familiar to you? And are you ready to be wowed? You probably already know this, but anyhow. Remember this number back here that I said every time was 4p? That number is also the length of the latus rectum. This number is so important. It tells me so much. It tells me which way it opens. It tells me where my focus and directrix are. And it tells me how long my latus rectum is. So let's talk about these blue points. Now let's use our common sense. What do we know about this distance all the way across? It's 4. So how far is it from the focus to one of the endpoints? 2. So if I start here at my focus, and I go 2 units to the right, where will I be?
5, 3,
5, 3. And then I go back, where will I be?
1, 3.
Now you have the end points of your Latus rectum. Awesome. Let's try another one. Definition of a parabola: a set of points in a plane equidistant from a given point in a given line. Okay, so here's another one. Let's do this. All right, here we go. Again, you recognize that's a parabola. Your job, we're going to find the vertex, axis of symmetry, focus, directrix, length of the Latus rectum. And I'll use absolute value because you're used to that. That means magnitude, right, or length. And we'll find the endpoints of the Latus rectum. So that's all the information we want to get out of this. Graph is not necessary. You'll just fill in the blanks here. You'll write down what all these things are. I can't do it without a graph, so I'm always going to sketch it, but you don't have to. Your graph is not going to be graded. Nobody cares if you have it or not. Tell me about this. Where's my vertex? 2, -1. Now here comes probably the most critical decision you're going to make. Which way does it open? It opens to the left. How do we know it opens to the left? Because it's y squared and it's negative. It's y squared and it's negative. So it opens to the left. Which means its axis of symmetry is what? Not x equals. Which
Y
axis
equals
does it cross?
-1.
It's y equals. Y equals -1. Whatever axis it crosses, that's the equation it is. Now, would you agree that my focus, I'll put my focus in red. Would you agree that my focus is in here somewhere? Which means, what do I automatically know about it? If it's on this line, I know what?
It's a -1.
Its y coordinate is -1. I need to know how far this is. I need to know how much to back it up by. How do I do that? I need P. And where do I get P? Always, always, always. That number equals 4P. So what's P? Which means I'm going to back up 2 to put my focus. So where will I be? 0. And if I backed up 2,
You're going up.
I'll go forward 2 for my directrix, which is a line. And if I go forward 2, where will I be here? Okay, that point would be 4, -1, but remember, the directrix is a line.
It's x equals
So
4.
x equals 4. Here's my Latus rectum. How far is it from top to bottom? It's 8. From top to bottom is 8. So to get this endpoint, I'm going to start at the center and go up. How much? 4. So if I start here at my focus, if I start here at my focus, and I go up 4, where will I be? What will be the coordinates of this point? 0. I went up 4. 0, 3. And if I go down 4, I would be at 0, -5. You're done. All right, let's do one more, and then I'm going to throw in a little complication. Vertex. Everybody good with that? Which way is it open? To the right. And we know it opens to the right because why?
Y squared.
It's y squared positive. Which means your axis of symmetry is right here. And it will have what equation? Which axis does it cross?
Y.
Where does it cross? Y equals 5. My focus is in here somewhere. Remember, nobody's grading your graph, so just stick it in there. What do you know about that point? You know the y coordinate is 5, right? In order to find the x coordinate, you need this distance, which for some reason we call p. How do I figure out p?
4p equals 6.
This number is 4p, so 4p is 6. That number is always 4p. So 4p is 6, which means p is 3/2 or 1.5. So if I go forward 1.5, where will I be? A half. If I go backwards 1.5 to get my directrix, where will I be?
0.5.
X equals, I'm intersecting the x-axis, x equals -2.5. There's my Latus rectum. How long is it? It's 6. Which means to find the endpoints, I'm going to do what? I'm going to start at focus and go up and down 3, because the whole thing's 6. So if I start at this point and go straight up 3, where will I be? 0.58. Go down 3, 0.52. Some kids like to use graph paper when they do this. Feel free to do that if it helps you. You okay? Anybody have a question about that? Because now I'm going to complicate it a little bit.
When you solve for y, what would that be called? Like when we did the y equals the 1.
What do you mean, what were you called?
What was that? Like when we did change it to y equals 1/4 x minus x squared plus 2.
I was just trying to show you that there are different forms of the equation, and you can use whatever form you want. So what's the complication here? When the equation looked like this, it was a really easy problem, wasn't it? Does that equation look like this?
Nope.
So what do you think I'm going to need to do first?
Do it like
Make
that.
the equation look like that. Now, you kind of got a taste of this last night, because how did you make your circles look right? What did you do? You completed the square. Guess what we're going to do? But the good news is, because there's only one square term, we only have to complete the square once. Unlike with the circles, where you had to do it twice. So first thing you need to do is get this equation ready to complete the square. So I'm going to multiply both sides by 3. Everybody okay with that?
Yeah.
Now what do you think we might do next?
Make the 6
Subtract
on the other
6,
side.
good idea. Oh, subtract 6. Now, are we ready to complete the square?
Yeah.
Half of 6 is 3 squared is, so I have 9 to both sides. Don't forget to add it to both sides. Same with your circles. Gotta add it to both sides when you complete the square. So we have 3x plus 3 equals y minus 3 squared. Everybody in agreement?
Yeah.
We're almost there. What's the last thing we need to do?
Factor out the 3.
Factor out the 3. Now does our equation kind of fit the mold that's made all the rest of that stuff easy? Yes, so now we're ready to go. Where is my vertex? Negative 1, 3. Which way do I open?
Right.
Everybody okay with right?
Yeah.
This then is my axis of symmetry, and what is its equation?
Y equals 3.
Y equals 3. Which means that my focus has a y coordinate of 3.
Yeah.
Strike, tell me that's not your breakfast. Tell me
No,
you're
it's
not
part-
eating Doritos for breakfast.
No, it's part of my work.
Oh, okay.
I'm kind of hungry.
I need this number right here. I need to know how far to the right to move. Where do I get that value?
You get it from 4p equals.
I know this number right here is 4p. So what's p? 3/4. So I'm going to start at -1 and go forward 3/4.
0.5.
So where will I be if I start at
0.25.
-1 and go forward 3/4?
Negative 0.25.
Negative 1/4 or negative 0.25? Now, if I went forward 1/4 to get my focus, I will go back. Oh, I had to go 4 1/4. I went forward 3/4. I'm sorry. If I went forward 3/4 to get my focus, I'll go back 3/4. And x equals -1 3/4, negative 1.75. Where's my Latus rectum? How long is it?
3.
It's 3 units. So I'm going to do what? How am I going to find this blue endpoint right here? What am I going to have to do? Go up 1.5? So if I go straight up 1.5, I'm at negative 1/4, 4.5, negative 1/4, 1.5. And we're finished. Okay, you ready to try one with your neighbor? All by yourself?
Are you? Maggie, it's been way too long. You're back.
All right, here we go. Don't forget, we're celebrating Pi Day on Monday. Make sure you bring your stuff. Yep. Oh, wait, up on Monday. go. With your neighbor, see if you can get this one figured out. Obviously, you need to put it in standard form first. Did you subtract 17? Did you divide by 2?
Yeah.
Did you add 9?
Yeah.
How's that look? I know there's a fraction in there, but you know what? We need to be able to do fractions. Fractions are part of life. And it's an easy fraction.
If the 2's in front of the x minus 3 squared, put 2 in front of them, does that change?
It doesn't change anything except then that number's no longer 4p. If you want to use that procedure, which is, I think, you have to admit that's a whole lot easier than all that junk you did last year with 1 over 4a, k, j, b, whatever. This is the format you have to use. Where's your vertex? 3, -1? Which way do you open?
Down, up.
Up? We in agreement? Up? What's your axis of symmetry then if you're opening up? X equals 3. Your focus is inside there. You need to go up, right? How far do you need to go up? Well, I don't know, but this number is going to tell me. Because I need to go up P. 4P is a half. So P will be an 1/8. So where am I if I go up an 1/8? What would be this point if I go up an 1/8? 3, -7/8. And if I went up an 1/8,
Down an 8.
I gotta go down an 8. What would this be? This is an equation.
-9.
Y equals -1 1/8. How long's that whole segment? Blue dot to blue dot?
It's a half.
It's a half. So to get the blue dots, we're gonna start here in the center, and we're gonna go forward and backward, how far? A fourth. If the whole thing is a half, you're gonna go a fourth. Okay, so I'm starting at the red point, and I'm going forward a fourth. So where will I be? 3 1/4, -7/8, and -2 3/4, not negative, just 2 3/4, comma, -7/8. We're starting at the red point and going back and forth 1/4. Tell me about that parabola, fat or skinny?
Skinny.
Skinny. The bigger this number is, the fatter. Because that number tells you how wide your latus rectum is. If that segment's a big number, that means you're big. If it's a little number, it means you're skinny. Okay, we're done. Tomorrow, we'll probably have a little quizzy too. So practice your homework problems. Or they're in the book, it's in the book. The homework's in the book. John, can you turn that off?